Hi everyone, welcome back to A+ Maths. I'm Heidi Postle. Thanks for watching the videos. I hope you've been enjoying them so far. Let's continue on with our quadratic equations. So today we're going to be doing quadratic equations using the formula. The formula looks quite complicated, but what we're going to do is show you some steps so that it makes it very easy and very doable. And at the end of the video, what I'd like to do for some of you who might be a little bit more interested is to actually show you where the formula comes from and how to prove it. So let's get started. The quadratic formula comes from the equation ax squared plus bx plus c equals 0. Now that's the form that a quadratic equation would normally take, where you have a number in front of an x squared, a number in front of the x, the constant, and then make it equal 0. Quadratic equations have to be in that form. And of course, as we've seen previously, there are different ways that we can solve those equations once we have it in that form. But this time we're using the formula. And the formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Wow, isn't that a mouthful? But it's not as complicated as it seems. The three main ideas of how to solve a question using the quadratic formula. There's really three steps that you have to follow. Step 1 is to find the value of a, b and c. We can all do that, whatever number's in front of the x squared, whatever number's in front of the x, and then whatever number is left next to the equal sign. So far so good. Step 2, that's going to be substituting it into the formula. And this is a little bit tricky because sometimes people get confused with the signs, the plus and the minuses. But what I want to do when I substitute numbers into a formula, I put brackets around everything that I substitute so that it makes it easier to work out what I'm doing. And then the third step is to simplify at the end. And that can be tricky because sometimes you need to remember your surds. Let's have a look at an example. 3x squared plus 5x minus 4 equals 0. Great. So we've got our formula. Don't forget, whenever you use a formula, always write it down. So there's our formula. We write it down. Now we need to find the values of a, b and c. That should be okay. Let's see. A is what? The number in front of the x squared. Great. A is 3. B is the number in front of the x. Well, that's plus 5 here, 5. And c is the number left, which is minus 4, the constant at the end. Now I need to substitute into my formula. But how do we do that without making a mistake with all the pluses and minuses? I like to put brackets around everything that I'm substituting in. So instead of writing b, I've put brackets. Instead of writing a and c, I've put brackets. And now all I'm going to do is to put the a equals 3, b equals 5, and c equals minus 4 into the right spots, like that. And now I work out whatever's under the square root. So what am I actually left with? Negative 5 plus or minus the square root of 73. Don't forget I worked out the 73 from the bit underneath the square root. 5 squared minus 4 times 3 times minus 4, which of course you don't have to do it in your head. You can use your calculator and get 73. And we're left with minus 5 plus or minus the square root of 73 all over 6. Be careful to put the 6 all the way across. All right, let's have a look at another example. 2x squared minus x minus 3 equals 0. Again, remember, you're going to use a rule. And what do we do when we use a rule? We write the rule. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's a mouthful, just write it down. Now what do? We need to work out what's a, b and c. A is 2, the number in front of the x squared. B is minus 1, the number in front of the x. And c is minus 3, the constant at the end. Be careful, make sure that it equals 0. We'll do questions in one of my other videos where it doesn't equal 0 and I'll show you how to rearrange it. But at the moment, we have them equaling 0. Now we have to substitute a, b and c into the formula. If it helps, write down the a, b and c's with brackets. And then sub the values of a, b and c into the right spots for the brackets. Is that okay? I hope everybody gets that. And what am I left with? X equals minus of minus 1 is plus 1, plus or minus the square root of Work it out on your calculator if you can't do it in your head. Bracket minus 1 squared minus 4 times 2 times minus 3. That's 25 all over 4. So we have x equals 1 plus or minus the square root of 25 all over 4. Don't forget that the square root of 25 is 5. So we have x equals 1 plus or minus 5 over 4. And don't forget the plus or minus means we have two answers, of course. It's a quadratic, we have two answers. So x equals 1 plus 5 over 4 or x equals 1 minus 5 over 4. They're the two different solutions. And then we simplify them and have x equals 3 over 2 or x equals minus 1. Did you get that? Do you understand what's happening? If you do, that's fantastic. Why don't you have a go at the next one without me doing it first? Pause the video and then see if you get the same as me at the end. Good luck. Let's see if you did it right. Here we have minus 3x squared plus 4x plus 1 equals 0. What did you do first? Hopefully you wrote down the equation. Then you wrote down the values of a, b and c. A equals minus 3, b equals plus 4, and c equals plus 1. Good. Now we have to substitute the numbers into the formula. Prepare the formula with brackets to get it ready so that we substitute the numbers in correctly and we don't make a mistake with any of the minuses. Did you prepare it first? I hope so. Now, subbing the numbers, did you get that right? Good job. And then what are we left with? X equals minus 4 plus or minus the square root of 28 all over minus 6. And what do we need to be careful of here? That square root of 28 could simplify. Did you spot it? Because 4 times 7 is 28. That means that I can write the square root of 28 is the square root of 4 times the square root of 7. And the square root of 4 is 2. So that can actually become 2 root 7. And that's what I need to put back into my simplification. So I'm going to have x can equal negative 4 plus or minus 2 root 7 all over 6. Again, this continues to be a tricky one because I hope you notice that you could factorize the top part of the solution. So I could take out a common factor of 2 and get 2 bracket minus 2 plus or minus the square root of 7 all over 6. Then I can cancel. 2 into 6 goes 3 times. So I cancel the 2 on the top, cancel the 6 on the bottom, and I'm left with 3 on the denominator. So I end up with x equals minus 2 plus or minus the square root of 7 all over 3. Well, wasn't that a little bit tricky? There was a lot of simplifying to do at the end of that question. Let's have a look at another one. 5x squared minus 7x plus 2 equals 0. Don't forget, pause the video, see if you can have a go at it on your own. I'm sure you can get it right this time. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You getting the hang of the formula? I hope so. Step 1 is write down the values of a, b and c. So what do I have? I have a equals 5, b equals minus 7 and c equals 2. Prepare our formula for our substitution. Put the brackets in because putting the brackets in makes it much easier to put the numbers in. And we're left with x equals minus 7 plus or minus the square root of minus 7 all squared minus 4 times 5 times 2 all over 2 times 5. Let's work that out. So we have x equals, well, minus 7 is plus 7, plus or minus the square root of, work the bit out on the calculator under the square root, 9 all over 10. Well, this one's a little bit easier because the square root of 9 is just 3. Works out nicely. So we have our two answers. X equals 7 plus or minus 3 all over 10. Don't forget there's two answers. X equals 7 plus 3 on 10 or x equals 7 minus 3 on 10. And then we work it out separately. So we have x can equal 1 or we can have x can equal 2 over 5. How did you go with that one? I hope you're starting to get the hang of them. What you should realize when you're doing quadratic formula is that you should be able to use the quadratic formula every single time that you're solving a quadratic equation, as long as you have it in the right form. Ax squared plus bx plus c equals 0. As I promised you at the beginning of the video, I'd like to have one more slide of proving the quadratic formula. Now be aware that proving the quadratic formula is really quite tricky algebraically. If you're interested to know where the quadratic formula comes from, then watch this video. If you don't fully understand the whole thing, don't get overly stressed, because this is a proof of where the formula comes from. The only thing you really need to know is how to use the formula and how to substitute the numbers in correctly to get the right answer. So if you don't want to watch the rest of the video, thanks for watching. Hopefully I'll see you soon. If you want to continue, you might find this really interesting. So let's go. Remember that to prove the formula, I said that we need to complete the square. But this time we're going to be completing the square with a, b's and c's, and that's what makes it tricky. So we have ax squared plus bx plus c equals 0. Now what do you need to do when you complete the square? You can't complete the square because of that a. You have to have a 1 in front of the x squared. So the first thing we need to do is to divide everything by a. So we get x squared plus b divided by a, x, plus c divided by a equals 0, because 0 divided by a is 0. Then we need to move the constant to the other side. What are we left with? X squared plus b over ax equals minus c over a. So far so good. Now we need to actually complete the square. This is the tricky bit. And remember, what do? We need to add half the number in front of the x to both sides. So what do I have? X squared plus b over ax plus, now we need to add half of b over a. And half of b over a is going to be b over 2a. Remember, because b over a times a half. So we've got plus b over 2a all squared on the left equals minus c over a plus, and of course we have to add it to the right hand side as well, the b over 2a all squared. And then of course it makes a perfect square. X plus b over 2a all squared equals minus c over a plus b squared over 4a squared. Because when you square a fraction, you need to square the top and square the bottom. Right, let's come up here because we're going to run out of space. I'm now left with x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Now, I don't want to lose too many of you, so because it's quite complicated with all the letters, I'm now going to take the b over 2a to the other side. And what am I left with? X equals minus b over 2a plus or minus the square root of b squared minus 4ac all over 4a squared. Now what? I can square root the top and square root the bottom of this section over here underneath the square root. So what do I have? X equals minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a, because the square root of 4a squared is 2a. It's starting to look a lot like the formula, isn't it? What's the problem? I need to get a common denominator. If you spotted that, good job. And what am I left with? Bingo, the formula. Isn't that amazing? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. It's quite interesting how the formula is proved. And if you could understand it, good job. If not, that's fine. You should just understand how to use the formula. That's pretty good too. Good on you. Hopefully I'll see you next time. I hope you enjoyed the video. Don't forget to like and subscribe. Bye.